In exercise 2b, we're going to use the same four formulas with the 5 variables: v, u, a, t, and s. Final velocity, initial velocity, acceleration, time, and distance covered. So we're going to draw time velocity graphs for each of these questions. A car travelling in a straight line accelerates uniformly from rest with acceleration of 2 meters per second. So let's start off with my time on the bottom and my velocity on the side. I'll just call it VEL. So from 0 to a certain speed, and that's going to be 30, the max up here. Max speed is 30 along this line here. So it then drives at a constant speed for 12 seconds along here and decelerates to rest in a further 10 seconds. So we've been given information. Let's fill our information in here. Time is 10 for the deceleration. Time is 12 for the middle part, so that's constant. We know the area under this inside here is going to be 12 by 30 here, and that's the distance covered, 360 meters in there. We have, in this case, we have the distance too. We're going to have half the base by the height, 300 divided by 2, 150 meters. And in the first part, we can get the time taken to get there. V is equal to u plus at, with my final velocity being 30, my initial velocity being 0. It should be equals, not plus. Plus acceleration, which was 2, times time. So you can see here t is going to be 15. So the area of this one is half the base of 15 by the height of 30. So I'm going to put my 15 up here. So the total time taken are these 3. The area, the distance covered, is half of 15 by 30, which is 225 meters, 15 fifteenths. So my total distance, and then we look at the questions. I'm just filling in my variables here, and we'll see what questions they're going to ask in a minute. Total distance is equal to 225 plus 360 plus 150. And that's going to be 735 meters. It's going to be 585 plus 150, 735 meters. The time spent decelerating. Okay, let's have a look in here. Just change the color to see this one. Time spent decelerating is the time. Well, we got that. We got our 10. Yeah. And that should say accelerating. Just change that. Accelerating. Time spent accelerating. We've worked out. We were given the deceleration and the magnitude of the deceleration. So let's have a look at the magnitude of the deceleration. So we look at v is equal to u plus at. So the v and the u change around here. My final velocity is 0. My initial velocity is 30 up here. And we have plus a times 10 was my time. So you can see here a is going to be equal to minus 3 meters per second squared. On to question 2. A car accelerates from rest to a speed of 20 over a 5-second time interval. Let's do our graph. Here's my graph, t and v. Accelerating from 0. We're told time to a speed of 20, so I've got my 20. Got my t is equal to 5 here. It then continues at a constant speed. Okay, so it then continues at a constant speed along here. We're not given anything about deceleration. So we want to calculate the acceleration. We have my initial velocity, my final velocity. We have my time, and we need a. And you can see from the equation, we would use v is equal to u plus at. So 20 is equal to 5a. So my acceleration must be 4 meters per second squared. And you can see that if you're going to go from 0 to 20 in 5 seconds, it is an average of 4 meters per second squared, or an acceleration. Distance covered during the acceleration, we could use v squared is equal to u squared plus 2as here, distance. Could we use s is equal to ut plus a half at squared too? We have all these variables. So my velocity is 20 squared My initial velocity was 0. My acceleration was 4, and we're looking for s. So s is going to be 20 squared, which is 400, divided by the 8, which is 50 meters. If we fill it in up here, we're going to get s is equal to the initial velocity 0, so it's just going to be a half by 4 by time squared, which is 5 squared. And that's going to be 2 by 25, which obviously again is going to give 50. So use whatever formula you see first. And the total time taken, given the total distance covered, was a quarter of a kilometer. So s is equal to 250. The distance covered in here was 50. So the distance covered in here is 200. So if we're going at a constant speed along here of 20 and we go a distance of 200, time is going to be that distance divided by the speed, which is 10 seconds. So total time is going to be 5 plus 10, which is 15 seconds. Okay, let's have a look at number 3. A car accelerates at 5 meters per second, 5 meters per second squared from rest. So let's have a look here. Time, velocity, again, it's going up and it's reaching a certain speed. Speed is 50 in this case. And we're told A, so just give me my triangle there. It then travels at a steady speed of 50 for 25 seconds. So they're giving me the time interval here, 25. And it finally decelerates to rest with a deceleration of 10. So we'll call that D. D is equal to minus 10 in here. So the total distance traveled, the average speed. Okay. If we look at our first triangle, we have U is equal to 0, V is equal to 50, and acceleration A is equal to 5. So we can work out time here. V is equal to U plus AT, 50. You can see what the answer is going to be, is equal to 5t. T is equal to 10. So if I want my distance here, so I need my distance as well for this first triangle. The second one is going to be 25 by 50, which is going to be 1250. That's my distance in there. So I've got my 10 seconds. So I've got my half, my base by my height. It's going to be half of 500, which is 250. And we apply V is equal to U plus AT here. We have my initial velocity is 50. They swap around. V is my 0. We have my deceleration, my A, which is minus 8, or my D. So if we can get the time taken there, we can get the distance. So 0, using the same formula, is equal to 50 minus 8t. So my deceleration is 10, not 8. Can't read properly. So t is equal to 5. And then half my base, which is this 5, half my base by my height is going to be half of 250, which is equal to 125. So total distance, and my 3 areas, my 250, my 1250, that's 1500, and my 125, which is going to give me 1625 meters. The total distance covered. We're asked for the average speed. Well, speed is equal to my distance divided by my time. Now I'm going to write AS for average speed because S is distance in this case. So average speed is going to be 1625 by the total time. We have a 10, a 25, and a 5, which is 40. 1625 divided by 40 is 40.625 meters per second. That's number 3. Number 4, a car accelerates at 3 meters per second squared from rest. Let's see this time, velocity. Accelerates from rest to here. What's my max speed? 60. We've got an area of a triangle. What's happening in this direction? It travels at a steady speed of 60 for 75 seconds. So I can put my 75 on. And then it decelerates to rest, covering a distance. So in this case, they're giving us the distance in here. 150 is equal to the distance. So you get the time straight away there. Half, if we call this x, half of x by 60 is equal to 150. That's 30x equals 150. So my time in that case is going to be 5 seconds in here. So a 5 and a 75. The time spent decelerating, that was part 1. We've just done it. So once you can see what you can do, do it, and then look at the question, or look at the question first. The total distance covered. So in this area here, I have A is equal to 3, V is equal to 60, U is equal to 0. So I can get my time. V is equal to U plus AT. 60 is equal to A, which is 3 times T. So T is equal to 20 in this case. So the area in that triangle is half the base, which is 20. Put it in by the height, which is 60. And 10 60s are 600 meters. So the average speed, so we need each distance, 75 by 60 in here. And 675 is 42, 4,500 here. So I'll add that to my 600, with 4,500. And then we were told the distance in the last one was 150. So just add these 3 numbers together. 5,100 and 150 is 5250. Average speed. Distance over time. 5250 divided by 20 and 75 and 5 is 100. This works out nice and even. 52.5 meters per second. Question 5. The car accelerates at 2 meters per second. So another time velocity graph. 2 meters per second. From rest to a speed of 40. So I've got my max speed here, 40. It then travels at a steady speed and decelerates. Travels, decelerates. So I've got my 2 triangles on my rectangle, or possibly a square. And deceleration here, A or D, is equal to -5 for my deceleration. Distance covered during acceleration. Okay, let's have a look here. What do I have? My initial velocity, my final velocity, my acceleration of 2. Need time. And you can see it's going to be 20, but put it into the formula. V is equal to U plus AT. 40 is equal to 2t. T is equal to 20. So the distance covered there, half the base by the height, half of 20 by 40. It's going to be 1040s, which is 400 meters. So that's in here in the first triangle. The distance covered during deceleration. Well, in deceleration, if we look at this one, I have A is equal to -5. My final velocity is equal to 0. My initial velocity was 40. So let's get my time. V is equal to U plus AT. 0 is equal to 40 minus 5t. So you can see t is going to be 8. Half of 8 by 40 is 440s, which is 160 meters. We're told the entire journey was a kilometer. So we've gone, what have we gone? 560. These two, 400 and 160, 560, which leaves 440 meters in here. So if we're traveling at a speed of 40 meters per second, 440 divided by 40 would have to be 11 seconds in here. 11, and we got the time here was 8. So the total time taken is 20 plus 11 plus 8, which is 39 seconds. On to number 6. A car starts with uniform acceleration and reaches a velocity of 27 meters per second in 9 seconds. Okay, you should be able to see the acceleration is 3. So up and stops. Velocity is 27 and time is equal to 9. Then in this one, the brakes are applied straight away. So it's 2 triangles in this case. And it travels in this here distance is equal to 54. So let's take the variables from my first triangle. I'm going to work out everything from here. So u is equal to 0, v is equal to 27, t was equal to 9. So we need a, you can see it's going to be 3. V is equal to u plus at. 27 is equal to 0 plus 9a in this case. So a is 3 meters per second squared. So I have my time of 9. We're looking for uniform acceleration in part 1, which we have 3. Uniform deceleration. So we have s is equal to 54. My initial velocity 27. My final velocity of 0. We could use v squared u squared plus 2as here to get my a. We can see what it's going to be hopefully. So that should be a v. No, I don't know what that was. V. So v squared is equal to u squared plus 2as we'll have to use here. So it doesn't work out as clearly as I thought. V squared is equal to u squared plus 2as. So 0 is equal to 27 squared. And it's going to be minus, a is a minus in this case. But I can leave it as a positive till we work it out, plus twice 54, so 27 goes into 54, so I'll leave it as twice 54 times s. So twice 54 by s is equal to minus 27 by 27, 1 minus there. So s is equal to minus 27 by 27 over 54 by 2. So that one divides into that one and leaves a 2, so we're going to get minus 27 over 4. Which is equal to 6 3/4, 6.75. So that's not s, that's a. Minus 6.75 meters per second squared. So that's the deceleration. The average speed for the journey. Okay, well, we need the distance covered. So the distance covered here in this one is half the base, which is 9. I can actually do that quick. Rather than doing both triangles, I can just do half the base by the perpendicular height. So have I got both times? I don't have the time over here. So let me apply v is equal to u plus at to get the time of the right hand triangle for the deceleration. 0 is equal to 27 minus 6.75t, and 4 of them is a. So 4 of them is t, so t is equal to 4. So now I have my 9 and my 4, so the base is 13 and the perpendicular height is 27, and that'll give me my total distance. So half of 13 by 27 is 175.5, and we're looking for the average speed, so that's my distance divided by time, which is 13. 13 13s is 169, which leaves 6.5. So that's going to be 13.5 meters per second for my average speed. And then the 2 times when the velocity will be 15. The two times the velocity will be 15. It's not seconds. It's of course velocity is meters per second. So the 2 times the velocity. So v is equal to 15. V is equal to u plus at. So it's somewhere here it was 15, somewhere going up and somewhere going down. We need the times that it was 15. So 15 on the way up, 15, u is 0, and a on the way up was 3. So 15 is equal to 3t. So after 5 seconds on the way up, the velocity was 15. And let's see on the way down, v is equal to 15. V is equal to u plus at. So 15 is equal to 27 is my initial velocity, and A minus 6.75 times t. So I'm going to have 6.75 t is equal to 12. T is equal to 12 over 6.75. Now it'd be handy just to use a calculator, but because I don't have one here, I'm going to just write 1200 over 675. 25 into both of them is 48 over 24 and 3, 27, and 3 into both of them is 16 over 9, which doesn't go down any further. So that would be 16 over 9 seconds after this point, obviously, because it's taken 9 seconds to get here. So we'd have to add 9 to that, plus 9. So 1 and 7 over 9 plus 9, so it's going to be 10 and 7 over 9 seconds after the start that the velocity will be 15. On to question 7. A car traveling towards P with a steady speed of 15, accelerated, so the car's coming along this way towards P, accelerated at a constant rate between P and Q. At Q, its speed was 25, at P was 15. So it's not starting at 0 this time. The speed was maintained as far as R. Okay, let's have a look at a diagram for this one. So it's coming along at 15. So 15 here. It reaches 25 meters per second. And then the speed was maintained as far as R, a distance of 980. So I've got our triangle here with a rectangle underneath and a rectangle beside. Total distance is equal to 980. The other information I have is that the distance is 980. Okay, 980 is the total distance. So let's look at where to start this. Well, we can get the area in here. If we call this, we don't know the time. So, or do we know the time? They do. The total time is 40 seconds. So if this is t, this is going to be 40 minus t to give me the total time of 40 seconds. So this becomes 15 times t, 15t. The one above it is half the base, half, and all of these added together will give me 980, the areas. Half the base, which is t, by the perpendicular height between here and here, which is 10. Plus, so that I've said 40 minus t, no, 40t, 40 minus t, plus 40 minus t by the height, which is 25, and all of that will give 980. So we multiply this out, we're going to get 15t plus 5t plus 40 by 25, which is 1000, minus 25t equals 980. So what have I got here? 20t minus 5t, bring it to the right, so I'm going to get 5t equals 1000 minus 980 is 20. So t is equal to 4. Then it asks us, does it ask to find time? It just asks us to hence or otherwise draw the time velocity graph of the motion and hence or otherwise calculate the acceleration. Okay, so if we look, the acceleration is between here and here. So my initial velocity is 15. My final velocity is 25. We've just worked out t to be 4, and we're looking for a. V is equal to u plus at. 25 is equal to 15 plus 4a. 4a equals 10. So a is 2.5 meters per second squared. So this is question 7. I'll leave it at that for this video. In the next video, we'll look at questions 8 on to the end of this section.